Okay, well, this is day two. For those of you guys in the classrooms, I presented your counterparts yesterday. We're going to talk about soil today. My name's Tommy Springer. I am Mrs. Springer's husband. For those of you that have her and Mrs. Jones, I work for the Fairfield Soil and Water Conservation District, and I'm the wildlife and education specialist for our office. And our office is right here in Lancaster, not too far away from where you're sitting right now. So I'm right over by Ohio University, so not too far away. Work here and do most of my work out in the field with plants and animals, but soil is a big part of our job here at the office. And it's something we're very passionate about and we learn a lot about as part of our jobs. And I hope you guys will learn something today too, beyond just knowing that soil is the stuff that you walk on out there. So we'll get started. And the first question I always ask, is it soil or is it dirt? And I always get a lot of answers. What's the difference between soil and dirt? Well, basically it comes down to this. Soil is going to be, when we talk about it, when we plant stuff in it, we use it for gardening, for farming. Soil is a good word or a good way of saying it. Dirt is the same thing, just when we have it where it's not supposed to be. So when you roll around in the mud and you come in and your parents are mad at you, or when the dog gets outside and plays in the mud. We have a small dog at home. He likes to dig holes in our front yard, and then his paws get all muddy, and Mrs. Springer has to clean him out and put him in the sink and wash his paws and wash all the dirt off of him. So dirt's kind of the bad word when we talk about this stuff, but really they're the same thing. So today you may hear me say soil, you may hear me say dirt, but really they're the same thing. Soil is just kind of the better way of talking about it when it's useful to us. Dirt is when it's somewhere it's not supposed to be. So trick question, soil or dirt, they're really the same thing. So now that we got that up there, what's in the soil? So if we were to go out in the schoolyard, or like this picture out in the middle of a field, and we dig a big hole with, say, a backhoe, and we bring that pile of dirt into the middle of the classroom and put it right on the middle of Mrs. Mock's floor and start poking through the soil, what are we going to find in there? What all is in the soil? Well, the first thing we're probably going to look at are living things. These things are moving around. They're going to catch our attention. And probably the one thing all of you, if you've ever played in the soil, has seen is worms. So we're going to have invertebrate animals, small animals, animals without backbones. Worms are something that all of us have seen at some point or another. When it rains, they crawl across the school parking lot, but most of the time they live down in the soil, along with a lot of other stuff. And you see that list over there on the side. We'll have insects like ants, other little beetles, other types of little bugs that live in the soil. The pill bugs are one of my favorite. Some of you may call them roly-polies. They're gray. They kind of look like an armadillo, and they roll up when you touch them. They don't bite. They're fun to play with and hold in your hand. You got some bigger stuff like centipedes and millipedes, which they can be a little scary looking sometimes with all those legs. They like to live in the soil. And then the last thing on the list, they're grubs, which are the larvae of a lot of beetles. They'll lay their eggs in the soil. They spend most of their life under the soil as a grub. And then when they grow up, they become a beetle and they fly away. Another one I didn't put on there that my boys love playing with at home are cicadas. Cicadas live most of their life in the soil, and then they crawl out and climb up a tree and kind of shed their skin and hatch into the grown-up cicada. And me and Mrs. Springer's kids love to run around and pick up those empty cicada shells off of trees. But most of the time they're living in the soil. So those are some of the things, some of the small animals that we might find living in the soil. Now, if we had a big enough shovel, if we use that backhoe, we might find some bigger animals in the soil. Now, if you're digging with a little hand shovel, most of these animals are going to run away from you before you can dig them out of the ground. But these animals live in the soil too. And you saw that worm on the last slide. Here's one of the things that loves to eat worms, which is a mole. We have lots of moles at my house. And if you walk through our backyard, they leave their little tunnels and they kind of push up from the ground. They push the grass up, and then when you step on them, that sinks back down. And they have little tunnels all over our yard. They live in the soil. And then now, as it's cooling off for the winter, I always wondered where those moles went, because the tunnels kind of disappear in the wintertime. And really, they just dig really deep. They get out of where the soil's cold and they go down deeper where it's nice and warm. And then some other larger animals you might see in the soil would be groundhogs. And even you that live in Lancaster probably maybe have a groundhog in your backyard, digs a hole next to your shed or next to the alley. So they'll live in cities, they'll live out in the country, they'll dig holes in the middle of farm fields. Groundhogs live in the soil all over the place. And then the last ones here, salamanders and snakes. I know Mrs. Springer loves her snakes, but they will sometimes use the mole tunnels or those groundhog burrows to live in. A snake doesn't have any legs or hands to dig a hole itself, so they can't dig their own hole, but they'll live in other animals' burrows. And then salamanders, a lot of times too, will live under the soil. Usually those are going to be in the woods or a forest somewhere where the soil's nice and soft. So you're probably not going to have any salamanders living in your yard, but if you went into the woods or the forest, you could find salamanders living under the soil. So those are kind of the bigger animals that we might find in the soil, but there's still other living things in the soil. And the next one we'll talk about are plants. So when it comes to plants, again, most of what we're talking about is going to be the roots. The grass out in the yard, you guys just came in from recess, that grass out there, their roots are down in the soil and they are alive. And then same thing with their seeds. So when the trees drop seeds, the flowers drop seeds, those are going to get down mixed in with the soil. And before they grow into a plant, they're still alive. So we consider those living things in the soil. And then the last word here, this mushroom hyphae, this is kind of interesting. And most of you have probably seen mushrooms growing maybe in your own yard, or if you haven't seen them in your own yard, maybe you've seen pictures of mushrooms. And what's interesting about mushrooms is most of the plant or most of the mushroom body lives under the soil. So this hyphae is just a fancy word for the mushroom roots. But the mushroom itself that grows out of the soil is kind of like the fruit. It's almost like the tomato of a tomato plant. That mushroom is just the fruit of that fungus that grows under the soil. So it's kind of neat. Most people think of the mushroom being the whole plant. That's really just the fruit part of it that grows out of the soil to spread the spores around, which act as seeds for the mushrooms or for the fungus. So we've got animals, we've got plants, and then the kind of the last living thing that we would find in that soil pile, if we had a microscope, we could have these things we just kind of call microbes, but they're really bacteria and viruses. And I know we talk about bacteria and viruses, the coronavirus, with COVID, everything's going on. We talk about viruses all the time. And most of the time we think of these as bad things. But when it comes to the soil, healthy soil has lots of bacteria and viruses in it. And those are good bacteria and viruses. So they help the soil out. They help digest some of the dead things that we'll talk about here in a minute. But a lot of bacteria and viruses are not harmful to people. They're not harmful to animals. And if all the bacteria and viruses were gone, actually the soil wouldn't be able to grow any plants. And if you took one spoonful of soil, so we talked about big shovelfuls and backhoe loads of soil, but if you just took one little spoonful that maybe you eat your applesauce with at home, that one spoonful of soil would have over 100 million of these microbes in it. So 100 million to 1 billion in just a single teaspoon. So there are really, really a bunch of these out there in the soil. So very, very important to soil health. Again, you're not going to see these without the use of a microscope. So you could dig through the soil all you want. You'll never see these things. This picture is just what they look like under a really powerful microscope. So of course, we talked about the living things that are in the soil. Well, if there's living things in there, there's going to be dead things in the soil too. And before you get all grossed out and you think about what possibly could be dead, if you've ever played in the dirt, most of this isn't what you're thinking of. One of the most common dead things in the soil are going to be leaves and sticks. So you think of all those leaves that just fell from the trees, they're dead. They're no longer alive. They're no longer attached to the tree. They're going to start decomposing into the soil, just like any stick that breaks off of a tree, or when the flower dies at the end of the summer, it's no longer alive. Now it's dead, and it becomes mixed in with the soil. So all of that's out there all the time. When you cut your grass, those grass clippings, all of that is what we consider dead plants or dead plant material that's in the soil. And of course, we're going to have dead animal parts too. Now this picture shows a deer skull, and that's kind of a extreme example. But remember all that other stuff I talked about at the beginning, all the ants and all the worms and all that stuff. They're dying. There's worms and ants dying every day. And when they live in the soil, they're going to be dead in the soil too. So those things become part of the soil after a while. But if we sifted through the dirt, we might be able to find a dead worm or if we looked really closely, a dead ant or something. So there's going to be dead animals in the soil too. And they're a very important part of the soil, and it's what we call organic matter. So this phrase over here, organic matter, if your parents grow a garden or grow flowers, organic matter is very important because that's kind of the vitamins and minerals for plants. They need that to grow healthy. They pull that out of the soil. If it was soil without any organic matter, the plants really wouldn't be able to live very well unless you put a lot of fertilizer in. So these decaying plants and animals, very, very important to the soil. And if we have soil that is really, really rich in organic matter, usually you get this dark, dark brown, almost black color. And when you have that, the term is, we call it humus. It's almost so much organic matter. It's almost its own special kind of soil, and we call it humus. And you guys will talk about this. It's part of your unit when you talk about soil. You learn the term humus. And I mention that because it's not hummus. Hummus is something entirely different. You buy this at the grocery store. Mrs. Springer loves her hummus. She loves to dip pretzels in it. I do not like hummus, but it is different than the soil with organic matter, which is humus. So if you see that in a book or in your Chromebook and you see that word, it's humus, not the hummus that has 2 M's in it. So don't confuse those. Humus is soil that's really good for plants. So rich in organic matter. So that's kind of the dead things we talk about in the soil. If you look, get all the living things out of the soil, you get those dead things out of our soil pile, and you start poking around in there some more, you're not going to be able to see this, but there's air and water in that soil too. And if you think about what happens to the soil when it rains, it gets muddy. You can make, blobs of soil, it sticks together. And that's when it has water in it. Well, as the plants soak up that water, or the wind or the sun evaporate the water out of the soil and it becomes dry and dusty, the water's not there, but there's still air in there. And there's lots of holes in the soil, and they may be big holes like worm tunnels or root channels. And if you look at these arrows, it kind of points at some of these big holes in the soil. And those are ones you can see with your eyes. And when it rains, the water's going to flow down through there. When the rain dries up, they're going to be full of air. But there's also hundreds and thousands of little tiny holes, what we call pores or micropores in the soil, that trap air and water in there that you can't see without looking at it through a microscope. But you won't be able to see those. But this is why we water our plants, because the roots will suck the water out of the soil, and plants need water to live just like we need to drink water to live. The plants need it too. So we water the soil, it soaks in, and then the plants have that water available to them. And then the last thing we'll talk about that's kind of separate from the soil are rocks and gravel. So chances are, anywhere you dig in the soil, whether it's your backyard, whether you went out in the school playground and dug, if you went out in a farm field and dug, you're going to find rocks and gravel mixed in with the soil too. And that's just part of what's in there. And some of that is what we call the parent material, which is how soil was formed. As rocks break down into smaller and smaller pieces, that's what actually forms our soil. Now, it could just be other rocks. Maybe, you picked up a rock out of your driveway and threw it out into the yard, and then it got mixed in with the soil. That's part of it too. But there's going to be rocks and gravel in there. And usually what we talk about, those are the ones you can see. Look at this picture. There's lots of rocks in there. Some of them are big, some of them are small. But you could go through there if you wanted to take the time and pick them out with your hands. Now, the next part of what we're going to talk about with soil are the pieces that are too small to see, which leaves us with the last thing. Take out the living things, take out the dead things, take out the water. We're never going to get rid of the air, and then take out all the rocks and gravel. And what we're going to be left with are mineral grains. And this is what we call the pure soil. This is our building block. So if you want to talk about soil by itself, this is what we're talking about. All that other stuff can be mixed in there, but the mineral grains are the pure soil that we deal with. And they come in 3 sizes. And we can break them down even further than that, but we categorize them into 3 sizes, 2 of which you guys have all heard of, and you might not have realized they were part of soil. But the biggest of them is one I think everybody's heard of, and that's sand. So sand is a part of soil no matter where you go. Here in Ohio, we don't have a lot of sand in our soil, but if you've ever went to Florida maybe you've taken a vacation there, maybe your grandparents live in Florida. The soil in Florida has lots and lots of sand in it. So sand is a mineral grain. It makes up soil, and it's our biggest of these mineral grains. And you guys probably all know how small sand is. Maybe you have a sandbox at home and you think those grains aren't very big. Well, that'll just give you an idea how small these other ones are. So our middle-sized grain is called silt. And that might be a new word to you. I know we don't talk about it a whole lot, but it's the middle-sized grain. It's also part of soil. And then the last one, the smallest, is another one probably all of you have heard of, and that's clay. And again, we talk about clay being a part of the soil, and maybe you've had modeling clay in art class, maybe you've made something out of clay. All that clay came out of soil somewhere, but when we look at soil, if we dig a pit or dig a shovel full of soil in the backyard, it's going to have all three of these in it. It's going to have sand, it's going to have silt, and it's going to have clay. And that's the key with soil. So I told you, what is soil, what's dirt? Well, to be soil, it has to have all three of these. So if you go in the desert, there's lots of sand blowing around. Well, is that soil? No, because it's just sand. So to be soil, it has to have all three of these. And there are places here around Lancaster where if you dig in the right place, you may find pure clay. And at that point, it's not soil anymore, it's just clay. But just remember, soil is a mixture of all three. Florida soil has a lot more sand in it. Most of our soil around here has more clay than it does the other two, but it's going to have all three in there. And you guys will, after I'm all done with the presentation today, I've sent in samples of sand, silt, and clay by itself for you guys to get up there and feel. So you're actually going to get your hands dirty at the end of class today. I know Mrs. Springer's class might not. I think you're going to do it in Mrs. Jones's class when you rotate with them on the next time you're here. But we can separate these out, and that becomes a challenge because, well, sorry, I'm ahead of myself here. This is just an example of the difference in sizes. So if we were to shrink ourselves down to say the size of an ant, sand grains would be about the size of a soccer ball to us. The silt grains are going to be about the size of these golf balls I'm holding in my hand in this picture. And then clay is even smaller, would be about the size of these little plastic BBs here. So again, sand, silt, and clay, very, very different in size, sand being the largest, silt being the medium-sized one, and clay being the smallest. And that's what you need to learn for your unit here in 3rd grade. When you talk about soils again in 6th grade, we get a lot more detailed on it. But right now, sand, silt, and clay, 3 different sizes. And just remember, sand is the biggest, clay is the smallest, and silt somewhere in the middle. So when you look at soil, it's all mixed together, which I talked about. I was behind or ahead of myself there, but they're all mixed together in what we call the soil matrix. So if we wanted to separate them, how would we do that? And I usually ask the kids, and I get a chance when I'm in the classroom to take some answers and to take some guesses. And I usually have some students say, well, I would just, maybe use some tweezers and pick the sand grains out and then go through and pick the silt grains out. We're talking about millions and billions of these grains. And actually the clay is so tiny, you can't even see it without a microscope. So you'd spend the rest of your life trying to pick sand out of the soil and it wouldn't be worth it. So what we do, and how I did it to separate out the sand, silt, and clay for your guys' samples there that you're going to feel later, is a process called soil sifting. And to do that, we use these things called soil sieves. And this is kind of a basic set. And some of your parents may have something similar to this, 1 or 2 of these in your cupboards at home. People that do a lot of baking will use something like this to sift out the flour to make cookies or cakes nice and fluffy. But this is for soil. And you can see down here in the bottom left, they've got these screens in there. And this one down here in the very bottom left, that's really so big, that's just going to get out those rocks and gravel that we talked about. But as you go up the line here, the holes in the screen get smaller and smaller until eventually we're left with just this solid pan, and that's going to be for our clay to get caught in. So these larger screens, the sand, because it's biggest, it's going to get stuck. The silt and clay will go down through into a different layer. And then this is how we actually do it. We stack them up. So this is a basic set. This is the set I have here in my office. So this is what I used to get your guys' samples. But we'd pour all of our soil that we dug, we pour it up here in the top and then shake these to get everything separated. And eventually the clay would get all the way down to the bottom and we have them separated out. So we can do that pretty quickly. It's pretty easy. A set of these sieves was like $100. So it was something our office bought. Now, if I was a professional, so there are soil scientists out there. I am not a soil scientist. I know a little bit about soil, but there are people that work every day with soil. They study it. They study what plants grow best in it. They study what's good for holding water. So if you really like playing in the dirt, maybe you want to be a soil scientist when you get older. Well, they have their own set of soil sieves, and it looks something like this. So this is a professional soil sieve set. And I counted them up, and I think there's 32 different soil sieves here with different size screens. So they get a little bit more exact with what kind of sand. There's different kinds of sand, there's different kinds of silt, and even there's different kinds of clay. I didn't care so much. I used the basic set because for your guys' presentation today, you just need to feel sand, silt, and clay. We don't need to get into all the differences that this professional set would give us. So to give you an idea though, soil scientists, they use a much bigger set of soil sieves. And when they want to shake it, they've got this fancy machine called it's a sieve shaker. You can stack it, you can raise this lid, so you could put the whole stack on there if you wanted. We can just have 9 or 10 like in this picture. But the problem, I don't have one of these because the price tag on it is pretty incredible. Just one of these machines, just one of them, costs anywhere between $2,500 and $4,000. So my office doesn't have that kind of money for me to shake some soil for third graders. So in a lab, they would use this. But what I have is a basic sieve shaker, which is just me. Now, this picture was taken when I visited a classroom a couple years ago. Those are a little bit older sieves that we had in the office. And we used to let the students shake the soil for us. Unfortunately, with COVID and everything going on, I couldn't come to your school today. So I had to do it ahead of time. But this is what we used to do. We just pick up the sieves by hand and shake them and shake them and shake them for a couple minutes, maybe 5 minutes, till our arms got tired and we would be done. Now, the best part about this is it's free. So other than the food I had to eat to get the energy to shake it, the cost was free. We can do it over and over. And that's what I do every time I want to sieve some soil, is I just pour the soil in the top and just start shaking them with my hands. And then this is kind of what it looks like when the process is all done. Now, I'm not going to start with a bunch of rocks and gravel in my soil because we get all that out. But as you shake it through the screens, you can see it separates it by size until eventually down here at the left, this would be our clay. Now, they use different colors, so it shows up in this picture. Clay and silt and sand are all going to be the same color depending on what soil it comes out of, but they will be different sizes. So these sieves do a really nice job of separating that out for us. And when you guys come up here in a little bit to the front of the room or wherever your teachers have the soil station set up, I really want you to focus on how the different grain sizes feel. Because most of you have already felt sand at some point in your life, whether it's been in a sandbox, whether you've been to the beach, you've probably all felt sand by itself and kind of have an idea what that feels like. Silt and clay are a little bit different. And even if you've played with modeling clay or Play-Doh or something similar like that, that clay has a lot of water added to it, so it sticks together. The clay you're going to feel here in a little bit is completely dry. So it's in powdered form. It feels really different than what most students expect. And I'm not going to give you any ideas of what it feels like. I want you to experience that for yourself, but hopefully it's not what you were expecting. And just for reference, for when you do get up there to feel your sand, silt, and clay, this is what it looked like before I sifted it. So this is the exact soil that I used to sift your sand, silt, and clay out of. And you see there's these big clumps, and this is a bunch of clay stuck together. Now I did crush it up, so it went through the screens, but that's what this soil looked like when we dug it out of the ground. Just to give you an idea here in a little bit when you get up there and get a feel of the soil for yourself. So shifting gears a little bit, we talked about what would be in the soil if we dug that hole. Now, let's pretend we jumped down in that hole and looked at the soil from kind of a worm's eye view, if you would. And there's layers of the soil. And this is important for what you guys learn about. So we call this the soil profile. When you talk about it in 6th grade, you're going to get even into more detail about the soil profile. But the soil actually forms layers under the ground, and it's not by sand, silt, and clay. The sand, silt, and clay is still all mixed in through these layers. But what happens is you get this top layer, and that's where that humus that we talked about developed. And it makes sense because if you think all the leaves that fall from the trees, all those flowers and weeds that die, and maybe some animals that are running across the top of the ground that die, they're going to be laying up here on this top layer. So that's where they start to decompose and mix in with the soil. So that's where our humus forms. That real rich organic matter layer is going to be up here at the top. And then a little bit more confusing that the topsoil is right here below the humus layer. So it does say top, so it is the top layer of soil, but it might not be on the very, very top because you've got some humus up here. And then you got subsoil below the topsoil. You get down here a little bit further and you're going to have soil with these big chunks of rock, which we call the weathered rock fragments. And then if you go far enough down, you're going to hit bedrock, which is solid rock. So there's no soil once you get down here to bedrock. It's solid rock, and what it might be sandstone, it might be granite, depends on where you're at in the world, but you're going to hit bedrock down here at the bottom. Now I throw this profile up here just to kind of show you guys what a soil profile would look like. But for 3rd grade, all you really need to worry about is topsoil, subsoil, and bedrock. So if you know about humus, that's great. If you know about these weathered rock fragments, that's awesome too. But for your lessons, for your tests, just focus on topsoil, subsoil, and bedrock, and you should be good. And like I said, easy way to remember, topsoil's on the top, bedrock is all the way down here at the bottom, and then subsoil, I like to think of that of a submarine. A sub means underneath, so submarines go under the water. So subsoil is going to be under the topsoil. So that's our layers of soil. Now I talked about on that last slide, we'll get back to that real quick, bedrock being down here at the bottom. And I usually ask the students, if I was there in person, how deep do you have to dig to hit bedrock? And I get all sorts of guesses, maybe 2 feet. Some people say 100 feet. Some people say a mile we'd have to dig down to hit bedrock. And really, all those answers are correct because bedrock can be anywhere. And here's a picture. You guys might recognize where this is. This is Mount Pleasant. This picture was taken at the fairgrounds. So that's Mount Pleasant in Rising Park. And if you look clear up here on the top of this mountain of Mount Pleasant, that's bedrock. That's bedrock with no soil on it at all. So if you've ever climbed to the top of Mount Pleasant to look over Lancaster, you're actually standing on bedrock. And where the trees are growing, there's some soil because the trees aren't going to grow right on bedrock. But the soil up there is only a couple inches deep. So you wouldn't have to dig very deep at all to hit bedrock. And in fact, if you were out here by where the hand railing is, you wouldn't have to dig at all. Now, if you go to other places around Lancaster, you may dig 200 feet and never hit bedrock. So like I said, the soil can be various depths, the bedrock can be various depths, but there is no right or wrong answer with how deep bedrock is. And this is just a perfect example because most of you have seen this right here in Lancaster, right around the corner from the school. So kind of to wrap things up, why our office exists, why I have a job, is because soil is very important. And one of the main reasons it's very, very important is it's because it's a non-renewable resource. And that might be a new word to you guys. I don't know if you've talked about that yet in 3rd grade, but a resource is just something that we use. And if it's non-renewable, that means we're not going to be able to replace it in our lifetime if something happens to it. So to kind of switch gears, a renewable resource would be something like an apple. If you take an apple off a tree and eat it, that resource is gone. That apple was a resource and it's gone now, but that tree can just grow another apple, maybe even in the same year, but next year it could grow another apple. So we're able to renew that or replace that resource in our life. A non-renewable resource is something that we're not going to be able to replace before we die. So soil, if we were to lose 1 inch of soil, I don't know if you guys can see me, but 1 inch, we're not talking about very much here. 1 inch of soil, if that was to wash away from your yard, or if you were to take shovels and dig an inch of soil off your yard and throw it in the trash, how long would it take to replace that? Well, here in Ohio, That's about 500 to 1,000 years just for 1 inch of soil to naturally rebuild itself. And that's not counting if you ordered a dump truck load of soil, because you'd have to steal that soil from somewhere else. We're just talking about natural replacement, 500 to 1,000 years. And I don't know about you guys, but I'm not planning on living 500 years. So I'm never going to see that 1 inch of soil replaced. So it is a non-renewable resource, which means it's very important to protect that. And just real quick, when we talk about how soil is formed, remember that bedrock that we see at the top of Mount Pleasant? As you're walking on that, you're breaking off little tiny pieces of that bedrock. You may not even see it, but it can come off. That's sandstone up there. It's kind of gritty. As you wear down that rock, as it rains on it and wears that bedrock away, those little grains become part of the soil. So that's one of the ways that we can form soil. The decomposition or biological activity, this term here, again, that's those plants and animals dying and decomposing and becoming part of the soil. So that's another way to form soil. And then the last one here, I mention it because it's one of the ways, this oxidation. And that's just kind of, if you set a piece of metal outside, maybe you've got a swing set in your backyard, and as it gets wet and is exposed to air, it starts to rust, and you get that orange flaky metal part that starts breaking off and crumbling. Well, that will eventually become part of the soil too. So that's some of the ways we naturally form soil. And this happens all over the planet all the time, but it is a very, very slow process. So kind of wrap things up. This isn't stuff you're going to probably need to know for your 3rd grade test at all, but it's kind of some neat information. We'll talk about some of the uses of soil. Some of them are going to make sense to you. Some of them might be kind of new ideas that you didn't realize we use soil for that. We'll talk about why, or ways we lose soil, and really just one way that we see around here. And then lastly, ways we protect the soil. So when we talk about uses of soil, again, if I was there in person, I would ask you guys, what do we use soil for? And usually the first hand that shoots up, the first answer I take is we grow stuff in it. And that's exactly right. So we grow plants in the soil. And this could be farmers planting corn and soybeans, which we have a lot of farms here around Lancaster, and they use the soil for growing their crops. It could be a garden at home. Maybe you guys grow tomatoes or green beans or something in a small area in your backyard, or maybe you just have some flowers around your porch. We use that soil for that. So very important for that. And then here in the middle, just think of all the trees and the grass and all the things that you may not have planted on purpose, but they still use that soil to grow. And think, if we didn't have that soil, none of those plants would be out there. And can you imagine, it would be like a desert with no trees, no grass, no flowers, not even dandelions or the weeds that we all like to hate. If we didn't have soil, they wouldn't be able to grow. So growing plants is probably our #1 use of soil, whether we're doing it to grow something to eat or whether we're just growing something to enjoy, such as the shade from a tree. So that's our main use. Now, another use that we see around here a lot, especially if you drive through Lancaster right now, there's a lot of this going on, and that's construction. So we build houses. All of your houses, whether you live in a house or an apartment or wherever you live, that house is sitting on soil. So we don't build our houses on bedrock. Bedrock is very hard to build on. It's hard to pour concrete, it would slip and slide and crack and do all sorts of things. So we build houses on soil. And you look at the picture over here on the left, a lot of you, if you have a basement to your house, we've dug a hole in that soil to pour those basement walls. And you have to have the right kind of soil. If you tried to build a house, just for an example, in the desert or right on the beach, that sand or whatever, that's not good for building houses on. And we have to have the right kind of soil. So construction, very important. Same thing with this picture on the right. This is just a picture of a pond being built. Mrs. Springer and I have a pond at home, and you have to have the right kind of soil to build a pond in. And again, if I was there, I could ask you, if you wanted to build a pond, would you want soil with a lot of sand in it or soil with a lot of clay in it? And, take some answers. But the answer is you need soil with a lot of clay. And if you think about it, if you're going to make a bowl in class, would you want to make a bowl out of sand or would you want to make a bowl out of clay? And sand would just let the water go through it. Besides, you wouldn't be able to get sand to stay in the shape of a bowl, but that's a different story. But that clay, those grains, those little tiny particles, remember I told you how small clay was, they pack together very tightly and they don't let water through. So if you wanted to have a pond, you got to have the right kind of soil with the right amount of clay. And in this case, they do because it's holding water. So if you tried to build a pond in real sandy soil, the water would just drain out the bottom and you never have you just have an empty hole in the ground. So soil is very important for construction. Those are the two big ones that we see all the time and you might be able to understand, but there are a lot of other uses for soil. And some of the ones you might not think about are this picture on the left, that's sandpaper. That's not a really good picture, but it's sandpaper. You know, we use that to smooth things. And all it is sand that's glued to a piece of paper and it's rough. So we can use that to polish wood or to take rust off of metal. But they got all that sand for that sandpaper out of the soil. So they had to have soil with sand in it to get that sand out to make sandpaper. So without soil, we wouldn't have sandpaper. And then the picture over here on the right, those are just some flower pots. Again, made out of mostly clay. Now these pots are called earthenware pots, so they may have some sand and silt mixed in with them, but most of those pots use clay that we get out of the soil. And then lastly, there are some other kind of odd uses for soil that you might not think about, but here's something you may recognize these people in this picture. This is Mrs. Springer and Mrs. Jones, and they have soil spread on their faces. So this is called a mud mask. It does it to make your skin healthy and shiny and smooth. And again, it's kind of like putting a little bit of sandpaper on your face. It smooths out your skin, and there's minerals in that soil that helps make your skin healthy. I'm not one to rub mud on my face, but obviously Mrs. Springer and Mrs. Jones did it, and I'm sure it made their skin nice and healthy for them. So people do this all over the place, and there are lots of other uses for soil that, you know, kind of depends on where you're at in the world and different uses, but I'm not going to talk about all those today. But these are some of the other ones that you see maybe on a pretty day-to-day basis. So we talked about the uses. So how do we lose the soil? And this is a big one. This actually, if you wanted to know why the Soil and Water Conservation District exists, this is why it exists, because we lose soil. And for years, we lost soil all across the country. And the main way we lose that is through what's called erosion. And again, if you've never heard of that, erosion is just when soil or rocks are moved from one place to another, usually by water or by wind. And about 100 years ago, we had a lot of wind erosion going on. Most of it happened out in the western United States, out in the Great Plains, Texas, you know, Kansas, Nebraska, and it was called the Dust Bowl. It got so dusty because the wind was blowing so much soil around that it became known as the Dust Bowl. And there was soil from clear out west that was carried by winds all the way to the Atlantic Ocean. So it was a very big problem. And that's actually why my office was formed, so we can help work with farmers, work with the construction companies that are building houses to make sure that this erosion doesn't happen too fast. Because remember, I told you, if that wind blows an inch of soil out of this field in this picture, it's going to take 500 years to replace that 1 inch of soil. So it's very important we keep that here. And you know, this picture with the rain and this water coming through this field, that's something that we still see a lot. And if you guys take a drive with your parents and you drive around and look at some farm fields right now, I guarantee you can find some fields that look like this with these little kind of river valleys, or it looks like where the waters carried the soil away. And it still happens today, even though our office is working with these farmers to keep this erosion down. And what happens is when this rain carries the soil away, it makes our creeks look like chocolate milk. And I'm sure you've all seen that after it rains, these creeks through Lancaster, you look over the bridge, you look down at that water, and instead of being clear, it's brown and muddy. And again, it just looks like chocolate milk rolling through that creek. And that's just that soil that's being carried off the fields or maybe out of your yard and getting it mixed in with that water and making it look all dirty. And it's going to carry that soil away. So those are some of the ways we lose soil. This is the biggest way. There's a few other methods, but erosion is the biggest reason that we lose soil around here. And so when we talk about how do we protect the soil, the main ways are to prevent erosion. And again, these are just some of the common ways we use to prevent erosion. This picture here in the middle, you've probably all seen this black stuff around where they're building a new house or building a new office building. And this black stuff is called a silt fence. So remember, silt is part of soil. This fence goes around the construction site, and it's just to keep all that soil that's exposed on the construction site from washing away. So if you look at this picture, we've got this nice sidewalk going down on the outside of the silt fence, and you notice it's nice and clean. None of this soil on the inside of the silt fence has been able to wash off the construction site and get on the sidewalk. So that silt fence is doing its job, keeping the soil on there till the construction's all done and we can get grass planted on it. And the grass will actually hold the soil in place. And that's what, if you look down here at this bottom left picture, we've got a picture of a cornfield. And all these green plants that are growing down here on the ground are what's called cover crops. And the farmers will plant these not to harvest, so they don't care about taking a combine through here or baling this up. They plant these cover crops for one reason, and that's to cover up the soil to keep it from eroding. And not all farmers do this. So you'll look at cornfields around Lancaster, and it'll just be bare soil between the corn rows with no cover crops on it. And that bare soil is very at risk for erosion. So we try to work with the farmers. Our office works with the farmers, plant these cover crops, keep the soil from washing away, and then it's there for the next year when they plant their next year's crop, whether it's corn or soybeans or wheat or hay or something of that nature. But we want that soil to be left. And then the last example down here to the right is all these big rocks put along the edge of this creek, where the creek makes a turn. That water goes really fast around that outside edge. And if those rocks weren't there, that water would actually wash away the soil. And you might have seen this right here by my office. We had a big problem. There's a bike trail that goes by Ohio University, and the creek, which is called Fetter's Run, goes right next to the bike trail. And there was a curve in the creek like this right by the bike trail, and it started taking the soil away, and it eroded almost right up to the blacktop. So that pavement was almost completely gone. And luckily the university came in and put a bunch of big rocks in there. That's not where this creek is, but if you've ever been on that bike trail by the university, you may have seen something like that, where they put those big rocks, and it almost acts like a suit of armor for the soil. So the water just bounces off those rocks, and they're too heavy for the water to carry them away. So they protect the soil underneath. So that's kind of the role of my job in my office, and why I deal with soil on a daily basis. It's not just talking about it with third graders or sixth graders or anywhere in between. Our job, we get paid to go out there and work with people to protect the soil. So that kind of wraps things up, and I want to give you guys plenty of time here at the end to touch the soil. And as I know, Mrs. Sines told her class, and for the rest of you, if you have any questions, write them down, get them to your teachers, and they can get them to me, and I'll make sure to answer every question you guys send me. I didn't have time to do that today because I wanted you guys to be able to feel your soil samples. But I threw up this cartoon here. It's kind of funny. The worm family living there, and the kid worm is complaining that there's a hair in his dirt because the worms will eat that dirt. Now, we think of eating dirt as being disgusting, but there are a lot of animals that require that soil to get their food from. So with that, I will stop sharing my screen and turn it back over to Mrs. Sines. If we have any immediate questions, I'd be happy to take those, but otherwise, just have your students get them to me by email, or get them to Mrs. Springer, and she can bring them home and I can get stuff answered. Mrs. Springer's shaking her head. She doesn't like talking about soil. I enjoy soil and science, and Mrs. Springer likes reading. So.
Well, Mr. Springer, thank you again for your wonderful presentation. I see my kids have written lots of questions all over their desks, so we'll get those compiled and send those to you. So thank you again, and we're looking forward to hearing back from you. So thank you.
Sounds good. I will try to get if you guys get those to me this week, I'll try to have them answered before Thanksgiving break.
Okay. Thank you, Mr. Springer.
You're welcome. Everybody have a great day.
Okay. You too. Bye-bye.
Bye.